Good morning, class. So today we will just go over a few of these questions from yesterday, and then you guys will study for your quiz tomorrow. So yesterday, something that I think you guys didn't get very clearly was how can I draw an inverse function if I've been given the graph of a normal function. And I want to kind of go backwards on that by looking at these graphs and then helping us figure out whether they are inverses of each other. So we have this graph over here, and we have this graph over there. And the question that's been asked of us is to determine if they are inverses of each other. Now, if they're inverses of each other, then their coordinate points will be flipped. On this function fx, the coordinate point is x is -1, y is 3. So if the green function is an inverse of that one, then I expect this point to be flipped. I expect it to be x3, y -1. Y -1, 1. And I can see that that's true. This is -1, 3, and this one is flipped. X is 3, y is -1. Let me check this other one down here. Its point is -4, -2. And on the inverse function, that point is, according to, if it's an inverse, that point is supposed to be -2, -4, which it is. So I can conclude that these two functions are inverses of each other. And like I told you guys yesterday, I hope you can see that it's as if that function has just been reflected along that line, y equals x. If I draw a straight line here through the origin, that line is called y equals x. It's as if that the function, the black graph, that function, it's as if it's just been reflected through that line to give me that image. So I can conclude that those are functions of each other. Next one. Let's look at this one. If I look at this question, is it a function? Move away. Is the green line an inverse of the black line? Or is the black line an inverse of the green line? Or are they both inverses of each other? Again, I check the coordinates. Always check the coordinates. This one is, this coordinate right here is x is -1, y is 3, just like the previous one. This coordinate on the black line, I expect it to be 3, -1, which it is. So I can conclude that it is, as far as these 2 points are concerned, they are inverses of each other. But I need to check the endpoints as well to see if they're also inverses of each other. So let me check the endpoints. This one right here is x is -3, y is 1. This one I expect it to be x is 1, y is -3, which it is. Again, since I have 2 endpoints that are inverses of each other, the functions are inverses of each other. And again, I hope you can see that it's as if it was reflected through this line, y is equal to x. So if I was given only the black line and I wanted to draw the inverse of this black line, all I would need to do would be to get the endpoints, flip the x and y axis, and then graph those endpoints somewhere else. So like graph the endpoint here, graph the endpoint here, then draw the curve. That's all I would need to do, only. So let's try that theory here. Let's assume we do not see the green function. So you guys close your eyes to the green function. I've been given the black function only. I've only been given the black function. And if I wanted to, this is the black function. It's the only one I've been given. I don't see the green function. You guys don't either. If I wanted to draw the inverse of the black function, all I would need to figure out is what are these coordinate points? What is this coordinate point right here? Oops. This coordinate point is x is 4, y is -2, right? This one here is x is 2, y is negative 4. And this one here is x is negative 1, y is 3, negative 3. Negative 3. Yep. So if I want to draw its inverse, I'll just flip all of those points and then connect them. Let me start with this one. Let me start with this point here. If I flip it, I get x is negative 3, y is 1. X negative 3, y is 1. So that point would be here. If I flip this second point, it would be x is negative 4, y is 2. X is negative 4, y is 2. So that point would be right here. Let's say that again. This one, let's going back a little bit. This one was x is negative 1, y is negative 3. So its flipped thing would be x is negative 3, y is negative 1. My bad. It's supposed to be here. Okay. And this one right here is x is 2, negative 4. So the flipped one would be negative 4, 2. So negative 4, 2. That one will be over here. And the last one, it was 4, negative 2. So it would be negative 2, 4, which is up there. So I have drawn the inverse function of this graph. That means the green thing was wrong. I've drawn the inverse function of this graph without, by just using the coordinates of that graph. Okay, so I want you to practice this one right here. First of all, you can pause it and then do it on your own. First of all, check if it's if they're inverses of each other. If they are not, draw its inverse. I want you guys to try that. The other thing that I wanted to tell you guys about was how to evaluate an inverse function. How to evaluate an inverse function. So if I wanted to determine what the value of an inverse function is, try this one. So in this function, this is the graph of fx. What you see here is the graph of fx, but they're asking me to evaluate the inverse function of 2. Now remember, if this is the graph of fx, just like we've seen from the inverses, if I wanted to draw its inverse function, I would just flip the points. If I flip this point, it would stay the same. If I flip this one 5, 5, it would actually also stay the same. So this is interesting because that function is its inverse. However, if I wanted to evaluate this f of inverse function of 2, remember I know that if I have f of 2, let's check from this graph. F of 2, when the input is the x value 2, the output would be the y value 3, right? When you're doing inverse functions, when you're evaluating them from a graph, the input will be the y value. So the input of the inverse function, if I wanted to find the inverse function of 3, my input would be the y value, which is right here. That would be my input. Then follow it, and then it would give me the x value. So if I'm trying to find the inverse function of 2 from this graph, my input, because it says inverse, my input, I will look for the value on the y-axis. I'll go to the y-axis, punch in 2, and then look for that value on the x-axis. So the inverse function of 2 is 1. Let's do another example. This one right here. They're asking me for the inverse function of 3. Remember, again, if it was a normal function and they asked me for the value of f of 3, if they ask me for the value of f of 3, I'll just go to the x-axis because that's where the inputs are for normal functions. Put in 3, look for the value on the y-axis. However, they are asking me for the inverse function of negative 3. So since they're asking for the inverse function, my input is going to be a value on the y-axis. So I'll just go to the y-axis, look for -3, which is just right here, follow it, go to the graph, find that value on the x-axis, so that's 12. What that basically means is that if I put 12 in the normal function, if I input 12 in the normal function, it will give me -3. That means if I put -3 in the inverse function, it will give me 12. Okay, one last example. This one, they're asking for the inverse function of -5. Again, the graph that I've been given is the graph of the function fx. If the graph that I was given was the graph of the inverse function, I would just read it off the x-axis. But they've given me the graph of the function fx, so I'll just look for -5 on the y-axis. Go to the y-axis, look for -5, see where it meets the graph, read that value on the x-axis, then you have your -1. Cool. I'm going to post this PDF so that you can practice with these questions. I just need you to do 3 practice questions. You can do like 4, 5, and 6. Okay, bye.